Investigation of curves, section 3, limiting behaviour. Video 2, finding asymptotes, parametric curves. If we have a curve defined parametrically, we can find its asymptotes by considering values of t for which x tends to plus or minus infinity and y is equal to a constant, or y tends to plus or minus infinity and x is equal to a constant. Let's have a look at an example. Find the equations of the asymptotes to the curve with parametric equations x equals 1 over t minus 3 and y equals 1 over t plus 1. Well, let's start by plotting this in GeoGebra and see what we can see. So to enter the equations parametrically, I'm just going to put it into brackets in the input bar. So my x coordinate is given by 1 over t minus 1. And my y coordinate is given by 1 over t plus 1. Sorry, I've made a mistake there. That should have been t minus 3. So there we are. That's plotted my curve. And you can see there's a discontinuity here. That's because I've gone from minus 10 to 10, and that's given me a break in the curve. So what I can do is I can go into the object properties and I can increase the range of t. So because t was going from minus 10 to 10, at that level of zoom there was a gap, but if I increase it, so from minus 100 to 100, then it's going to appear as a smooth curve now. There we are. Okay, so it looks as if there is an asymptote at y equals 0.25, and then it looks as if I've got a vertical asymptote at x equals minus 0.25. Let's see if we can deduce these looking back at our function. So to find asymptotes, I want to find a value of t where x tends to infinity, and then find the corresponding value of y. So, as t approaches 3, x tends to infinity, and at that point, y is equal to 1 over 3 plus 1, which is 1 over 4, which is 0.25. And I spotted that when I looked at my graph. And then as t tends to negative 1, I have that y tends to infinity. And at that point, x is equal to 1 over negative 1 minus 3, which is 1 over negative 4, going to give me negative 0.25, which is the vertical asymptote which we spotted at x equals 0.25. Now, alternatively, I could have converted from parametric to Cartesians, and I could have used the same techniques that I did in the previous video to find the asymptote. So let's have a look at how we would do that. So x is 1 over t minus 3, so I can rewrite t equals 3 plus 1 over x, and y can then be written as x over 4x plus 1. And then I can think about what happens as x tends to infinity, and also when 4x plus 1 is equal to 0, and checking that x is not equal to 0. In this video, you've learned how to find asymptotes of curves defined parametrically.